Hi, this is Marcus. This talk is recorded for the September 18, 2021 IS4SI Summit Philosophy of Information Conference. This talk can be downloaded to watch later or to pause and repeat specific sections as needed. Okay, to frame a theory of meaning, one must first consider what is information. So I will start with a general view. When I say information, I point to the known cosmos, all material reality with mixed forces and matter. This unbroken, self-evident universe has no interpretive needs or logical gaps. It shows a necessary unity long before the arrival of modern humans with fractured views of information. We often call this unified primal reality, nature. Next, nature brings sentient life. Sentience has agents giving meaning to reality, experienced as life and death. That sensed reality is individual and discrete, partial to each agent with diverse niches where agents prove survival skills. But survival varies in each case with many ways to live one's life. In turn, mixed views of survival incite subjective biases. Still, any and all survival strategies show biological and behavioral adaptation with life-death as a central meaning. This interactive material reality with diverse referential agents I call an informatic system, and what fills that system I call information. Information is thus content to an informatic system context within a vast continuous material reality. Such common sense views are often missing from information studies, but are pivotal to framing deeper issues. Without a firm starting point, later analysis is often imprecise. Step 2 next shows a narrow scientific view of information. Here, Claude Shannon's 1948, A Mathematical Theory of Communication is key, dividing the engineering problem of signal mechanics from the meaning innate to all messages. This logical split allows one to isolate logarithmic and statistical traits in all messages, which Shannon called entropy. Signal entropy is now the scientific standard in depicting information, a widely accepted view, but with clear gaps. For example, in 1949, Shannon and Weaver called signal entropy disappointing and bizarre, as it omits meaning and it trying to equate the two types of entropy. But they also believe these gaps can be closed with a practical theory of meaning, the goal of this talk. Toward a theory of meaning in 1952, a semantic theory of information first appears, but wins little acceptance, as with all following efforts. Later, Shannon notes signal entropy's growing role, where many people gloss over clear gaps in the model. Today, 70 plus years later, a missing theory of meaning still plagues diverse researchers in many areas. Despite signal entropy's gaps, a theory of meaning seems likely as suggested. One candidate is metadata, often called data about data. For example, the standard model of particle physics and periodic table are each metadata, holding material primitives in a specific order to mirror reality. Thus, metadata are better called knowledge about data or knowledge about reality. Beyond metadata, meta-meta views also exist. A meta-meta view uses logical primitives instead of material primitives as a base. Logical primitives are domain-neutral elements that allow one to frame a general vista. This contrasts to domain-specific material primitives. One early meta-meta example is dialectic logic, born of a pre-Socratic era. Darwin's natural selection of diverse evolving species is also meta-meta. Lastly, Shannon's signal entropy is meta-meta, with logarithmic and statistical primitives that apply to all messages. To better show signal entropy in relation to logical primitives and a theory of meaning, I next reduce signal entropy to core elements. First, if we accept signal entropy as a valid concept, We must also accept Shannon's split logic of objective engineered elements as existing apart from semantic meaning. Ideally, a theory of meaning would then join those two facets in one coherent role. Thus, I call this approach subject-object modeling, or SO modeling. Semantic roles show in many ways, depending on the context involved. So naming a semantic logical primitive is the key task here. Second, Shannon starts his study with a message selected at another point, sent across the channel. But for a priori analysis, unlike Shannon, we must first ask, what is it that even allows a message to exist? Messages start with agreed upon objects, symbols, and sounds as base terms. For example, many writing systems and languages exist today. Each such group of agreed terms I call a set, and each marks another type of metadata. Likewise, the standard model and periodic table each show settled terms in nature's messaging. Normalized sets, whether man-made or natural, already show a meaningful difference with regular features and being well ordered. As such, space-time order at a most basic level is a likely logical primitive in an eventual theory of meaning. This view of base meaningful roles collides with Shannon's claim that semantic issues are irrelevant to the engineering problem, as all messages plainly arise from agreed upon sets. In fact, mathematics itself consists wholly of sets of various settled terms, each noting diverse space-time roles. This is the same for Shannon's logarithmic and statistical views. I herein refer to such meaningful data sets as set entropy. Next, specific groups of object terms frame each message. For example, numbers can have identic terms where different space-time roles alone invoke different values. But new object terms also incite new space-time relations to produce different messages and meaning. Joint subject-object operation makes S and O coevolve in driving messages and meaning, which I call group entropy. Lastly, the scale of subject-object grouped terms also shift messages and meaning, but at yet another entropic level. Shifting SO scales mirror Shannon's notion of a scalable logarithmic base that is sometimes called statistical surprise. But they do little more than extend already named space-time traits from above. At this point in the analysis, we come to the same place where Shannon begins his level A entropic study that he uses to develop signal entropy. In summary, shown above is what affords a message prior to Shannon's signal entropy. It starts with base elements instead of a message selected at another point. Each of the three entropic levels invoke a different objectified space-time role, again, making space-time a logical primitive in a theory of meaning. Further, SO modeling shows a central dualist role, coevolve subject and object. With the three entropic levels, this creates a dualist triune pattern. Lastly, eliminating any one of the named dualist triune roles defeats signal entropy as one would expect in a non-priori analysis. Beyond this reductive vista, higher order semantic roles also reduce to essential space-time traits. But explaining higher level semantics goes beyond the current goal. Still, at this point, it becomes possible to formally define information in these terms. As a final note, I invite you to read the companion paper that goes into more detail and indeed looks at higher order semantic roles. And I also leave you with a few other dualist triune functions. Thank you for your attention.
Very much. Well, let us have some discussion now.
Well, first off, is Ben online yet?
Okay. Do we have any comments? would you like to tell us a little bit, like Marcus, 2 sentences or 3 about the main message of your presentation, because it was nicely presented, but it would be good to see the kind of sum up. Was the main message?
Yeah, it of course ties into the talk that Ben was supposed to give, I imagine, about pattern recognition, essentially. And the end point of this presentation of mine is that it names a dualist triune pattern. And it does that first off by identifying subject-object roles, which is essentially the thesis that Shannon puts forth in developing signal entropy. I then articulate different ways in which subject-object roles appear within signal entropy. And from that, you derive a dualist triune pattern. When I first came across this, I was really a bit surprised or doubtful about finding or naming this dualist triune pattern. But the more I looked at it, the more common I saw that it was. You see it in base pairs and triplet codons in DNA. You see it in the states of mass in solid, liquid, and gas. You see it in natural selection. You see it in the storyteller rules of threes. You see it in space-time. Space-time is dualist. Space is height, width, and depth. Time is past, present, and future. Another, absolutely central dualist triune role. So there's this dualist triune pattern that seems to occupy all of nature. And it also ties in with signal entropy, which I showed in the presentation as a dualist triune pattern. So yeah, that's really the essence of what I have to say.
Thank you very much. Do we have any questions at this point?
Well, of course, you can imagine this is why I wanted to watch Ben's presentation. I'm very interested in hearing what he has to say about pattern recognition and what his thoughts are on this. So I'd be very interested in seeing when and if he comes online.
Well, I'm sure he comes, just he may be coming a little bit later than we would be expecting.
Krasimir has a question, it looks like.
Okay, please. Don't ask for permission, just speak, please.
Okay.
Hey, Krasimir, nice to see you first off. I want to say nice to see you.
Yes, nice to see you too. It is a very interesting presentation, very exciting, very useful for students to show the growing of understanding of information. I see from philosophical point of view 2 different areas of concept of information, and our big conference is proving of this understanding. First is I will explain one as joke. In Bulgaria, first photocopied copiers were from Xerox, and everybody say, can you Xerox copy my paper? After that, all photocopiers in Bulgaria are Xerox. And usually you may listen, my Xerox is Canon, my Xerox is Minolta. So such concept is used as generalizing the whole class. In the same time, there are concrete photocopiers Xerox. I think the word information is used in the same way. We have 2 kinds of using of the word information. Yeah. First, at the social level, we call information everything. Everything is information. Signals, reflection, data, knowledge, everything is information. And this is very expensive, because in every case we need to specialize about what information we talk. In professional area, we use concrete concepts, data, database, knowledge base, and we avoid word information from special works because it is so not so clear what I want to say, and I need to every time to specialize what I want to what I means. Because of this, we have such a situation with concept information, and I think we could not do anything to change the situation. The same is in Bulgaria. If you now try to change Xerox with the photocopier, it is impossible. People already know that Xerox is photocopier machine. Nevertheless, what is the main manufacturer? So the information now in the society became at the same level. Everybody use information for everything, and this in this situation, this means nothing. So I think we will come to the difference between two parts of people. Non-specialists will use information for everything, and specialists will use concrete concepts for concrete different kinds of information. So
Krasimir, if I could say, from what I recall reading of your own work, you have looked at subject-object relations yourself. And I think Wai-Zin out of China has also looked at subject-object relations. You're the only two that I know of that have really looked at this. And you two are the only two that I've seen that really understand this dualist nature of information. Obviously, Shannon understood it, and Weaver understood it with their paper. And then when Shannon comes out with the bandwagon paper in, I think that was 56, it was very clear that there's this problem that's never really been addressed until now, I think. But again, you know, this pattern of pattern recognition in the nature of information, both as an objective form and also in a form of meaning, I think is possible. And I think what my work might add is that it uses space-time as kind of a core metric to counteract or to be to hold the other side of the relationship with Shannon entropy.
Yeah, I think it is good to achieve that everybody may define information as he prefer, but to range the area where this concept works. I think this is the only way to find peace in our society.
Yeah, I agree with that absolutely. And I know Terry Deacon has talked about this as well, that you have to be very clear about your levels of abstraction when you're presenting information. You know, what is the level of analysis you're really looking at when you're talking about information? Korzybski also said this. He talks about levels of abstraction in his own work, but he never really details what those levels of abstraction are. I know Terry Deacon at least goes into, he talks about referential, normative, and I forget what the third one is. But he also Terry Deacon at least talks about specific levels of abstraction and how they are structured both in objectified information and meaningful information.
Yes. Okay. Nice. I think we think equally.
Yes, I agree.
Yeah.
Excuse me. Excuse me.
Yes, Arturo.
Yes. May I show a picture?
Talk to Peter. Peter, if you want to get permission.
Do you see this? Do you always see this picture?
I see it.
Yes. Here is a picture with a very low amount of entropy. Here it is a picture with very high entropy. Here, the two figures here have more or less the same amount of entropy, but the semantics, the meaning is completely different. So why do we say that Shannon entropy that expresses in bit defines some information? The information of Shannon and entropy, even if it's the same here, is completely different in in its semantic content. So I am very doubtful at the moment about the Shannon entropy to define this flow of information or knowledge.
Well, I agree with that assessment. I think that my guess is that most people on this conference would agree with you as well. Yeah, you were in raging agreement on this point.
Yes. May I say one word, Arturo?
Yes.
Your first two pictures, you think that entropy is very great, but from my point of view, this is not so true, because I may say the first two pictures are marble, which we use to put in our walls, or it depends of what I expect from my information expectation. Entropy could not be measured without what you expect. If I expect that this is some examples of marble with some book cover, it is not entropy. Do you understand me?
Yes, I'm not. I do not agree, to be honest, completely. But I understand your position. But there is always the problem that do you see now this?
Yes.
Here is a CD-ROM with 700 megabyte, and with the same amount of megabyte, it may encompass both a Beethoven symphony and both music from YouTube. So the value of 700 megabyte, that is the value from Shannon, it's completely useless to understand the content. I'm sorry.
Well, I think there's a central problem in how we use the term entropy. I think it suffers the same issue as information, because we use entropy to talk about information in Shannon terms. We use entropy to talk about it in terms of physics. But physics is made up of much more than just thermodynamics. Physics has four fundamental forces. It has weak nuclear, strong nuclear, electromagnetic, and gravitational. Each one of those forces defeat the natural tendency towards dispersal, which entropy argues for. So in physics, there's not a clear definition of entropy. We sure don't have a clear definition of what entropy is in information. And I think if we had better clarity on what the relationship was between entropy in practical terms and with entropy or forces, fundamental forces in physics, that would bring a lot more clarity. But we don't have a unified field theory for energy or force in physics. We have four fundamental forces, and they somehow become 16 forms of energy. But we don't really have any precise calculations or terms for understanding this. I always chuckle whenever I see Richard Feynman. He has his messenger lectures, and he says at different points in these lectures, the question of what is energy and what is energy is a very interesting question. And then he immediately he pivots and goes in an entirely different direction and leaves that question hanging. And he never answers that. And I've never seen anyone else really answer that question, what is the essence of energy? And we have energy as a capital E, as an E equals mc squared, but that's just a philosophical concept. That's not really an actual physical construct, unless you are talking about a specific form of energy. So that's tremendous problems with the use of the terms entropy.
Yes, but yes, if we are not even able to define the concept of energy, how could we define the concept of information? Yeah. Are we sure we require the concept of information in our scientific life or in life in general? I'm starting to be skeptical about the very concept of information, because it's something completely not quantifiable. I'm sorry.
Well, I see that David is signed on as host now. David, are you going to take over and give us to Ben, or is he not showing up, or what's the status? David, Peter, anyone there?
there. Thank you very much for the introductory lecture.
Where's Ben?
I think Ben is going by his schedule, but randomly he was misinformed because he's got confusing information, you know, just based on scheduling. So
So the laws of entropy being what they are, he's not made it to the meeting.
no, hold on. He's making it to the meeting. He's making for the second part, where actually Steve Thaler and Kate Gandhi were supposed to be, you know, the main speakers. So we have a very, we have Kate Gandhi in the room already. Thank you for Kate for showing up. And we have Steve Thaler on my phone. He's rebooting his computer in his office. So we are going to go with the discovery engines and doubles in particular first. And Ben is going to go when he expected to go as of last night, because he really wanted to go first. And that would be in about over 1 hour, you know, in 40 minutes. So now,
All right, I'm going to bow out. I'm going to bow out now, but thank you for the chance, the opportunity to let me present my work in this ad hoc way. Thank you.
Marcus, and thank you for your interesting presentation.